Hey everyone, today we are diving into matrices. Think of a matrix simply as an ordered rectangular arrangement of numbers or functions. When we lay it out, the horizontal lines are rows and the vertical ones are columns. If a matrix has m rows and n columns, we say its order is m cross n. It's the foundation for everything else we will do. As you can see, the matrix A has elements A11, A12, A13, A21, A22, A23, and it's the rows and columns, order 2 by 3. Next, types of matrices. Now let's quickly meet the family of matrices. If the number of rows equals the columns, it's a square matrix. If all elements except the main diagonal are 0, it's a diagonal matrix. If those diagonal elements are all exactly number 1, it becomes the incredibly important identity matrix, denoted by I. And if every single entry is an absolute 0, it's a zero matrix written as a capital O. So, as you can see, that is the square matrix. The rows and columns, the number of rows and columns are same, 2 by 2. Diagonal matrix, so there are the diagonal elements and other elements are 0. Identity matrix 1 0 0 1, so only the ones are there in the diagonal. Zero matrix, every element is 0. Next, moving on to the operations, that is addition and scalar multiplication. So this is the matrix algebra. Next, you can add or subtract two matrices element by element, but here is the golden rule: they must have the exact same order. If you multiply a matrix by a constant scalar like k, remember that k goes inside and multiplies every single element individually. So this example, you can see the first matrix has elements a and b, second matrix has element x and y. So the addition will have elements a plus x and b plus y. So order must be same, 1 cross 2 is the order in this example. And another operation is the scalar multiplication. So k is multiplied to each and every element of the matrix. So it is multiplied with a, b, c and d. Next, moving on to matrix multiplication. We can only multiply a and b if the number of columns of a matches the number of rows in b. Look at this pattern. The inner numbers must match and the outer numbers give you the size of your final matrix. Also, remember that order matters. AB is not equal to BA. Usually, sometimes it may come equal, but usually, in general sense, it is not equal. So, that n is same columns of A matrix and rows of B matrix. Then only it can be multiplied, A cross B. And the final matrix will have order m cross p, the number of rows of A multiplied by number of columns of B. So it's not commutative. AB is not equals BA. Next, moving on to the transpose, symmetric and skew-symmetric matrices. So in transpose, we can either write it as A dash or A transpose A raised to T. So it's simple, you just flip your rows into columns. So using this transpose, we get two special matrices, that is the symmetric and skew-symmetric matrices. So if it changes nothing, A dash equals A, it's symmetric. If flipping it makes all signs negative, A dash equals minus A, it's skew-symmetric. And in skew-symmetric matrices, the diagonal elements will always be 0. So in exam, it's a very favorite trick that proves that any square symmetric matrix can be split into the sum of symmetric and skew-symmetric matrix. So this is the formula: A equals half A plus A dash plus half A minus A dash. And you can see the diagonal element is 0 in a skew-symmetric matrix. Next is the invertible matrices. Finally, this is the last topic for this video, invertible matrices. If you multiply matrix A by matrix B and get the identity matrix, then B is the inverse of A. Keep this key property in mind for quick conceptual questions. The inverse of AB reverses the order, becoming B inverse times A inverse. So this is the entire concept of matrices summarized. So drop a like if this helped you visualize the chapter, and I'll see you in the next video. You can like, comment, share, subscribe, whatever you want to do. Thank you so much for watching.